You tell me how to solve this. Who thinks they know how to solve this? Trip. Proportion. That's one way to do it. That's absolutely right. What's something somebody else tried? That would have also worked. That would have also worked. These problems, if things are proportional, now what I didn't tell you was that in the directions it told you these were proportional. When things are proportional, it's literally harder to mess them up than it is to get it right. All you have to do is set up a proportion in any way that you think it could possibly make sense. Some people use, hey, big side, small side, small side. Some people did same triangle, and they're both right. You do them both, you get the same thing. What will this one be? 40 equals 8x. This one will be 40 equals 8x. They're literally harder to mess up than they are to get right. The only possible way you could have messed this up is if you did it in backwards order. For instance, if you did 10 over 8, see how we went right to left? Then you need to go right to left again. The only two ways you could possibly mess this up is to mix that up, like 10 to 8 and then 4 over x. See how that's an inconsistent order? Or you could have done 10 and 4 and 8 and x. I don't know why you would have put those two together, considering they're like the least, similar things on the page. So both of those are correct, and you should have gotten x equals 5. Should have gotten x equals 5. Today we're just looking at little parts of proportions. We're looking at things that you can assume about proportions. And instead of doing this one slide at a time, because I messed up and found my lesson, we are just going to do all the notes in one fell swoop. So while I'm putting these notes on the board, Justin, thank you for volunteering, is going to come around and pick up your DOMs. Justin's going to come around and pick up your DOMs, and he's going to wake Drew up on his way. Excellent. And here we go. The notes. Actually, hold on. What was the top one? Yeah. The notes are here. You do not need to write down all the words. You probably do want to write down all the little colored letter diagrams on the right-hand side. That is what will be helpful to you. Aww. The first one says, now notice, all three of them just start with A over B equals C over D. All that is to show you is that, hey, if you start with a normal proportion, then. So assuming that you start with just some random proportion, A over B equals C over D, these are three things you can know. First one, you can flip them, and it's not going to change anything. A over B equals C over D is the exact same as B over A equals C over C. As long as you flip both of them, it doesn't change anything. Like 1/2 equals 3/6. Flip them both. 2 over 1 equals 6/3. Same exact thing. That's all that one says. Number 3. This is an actually interesting one. It says if you pair up the numerators and pair up the denominators, it will also equal. I'll show an example of that. In fact, I'll just stick with the same example. 1/2 equals 3/6. Here's an example. Oh, darn it. 1/2 equals 3/6. It would be the same thing as if I paired up the numerators, 1/3, and I paired up the denominators, 2/6. Same thing. That's what the number 3 says. If you pair up these and these, between these and these, then you get the same thing. The fourth one is a little bit more outside the box than the others. It says, you start with this proportion. If you do nothing more than to add the two denominators right there to the top, then it won't change it either. Again, let's look at the same exact example. So if you started with 1 over 2 equals 3 over 6, and you added both denominators to the top, that would be 1 plus 2 is what? 3. 3 plus 6 is what? Yes. 9. Are those the same? Yes, they are. All we did was add the denominator to the top, and you get the same exact proportion. All today is looking at more and more proportions and just little variations of them. That's it. Now let me tell you what you're going to have to do in like 4 seconds. I'm going to put proportions on the board, and it'll say if, and it'll give you a proportion like this one. Then it'll say this part, but it'll leave a blank, and you have to figure out which of the rules they used and fill in that blank. Let's look at it. If 8 over x equals 3 over y, then 8 over 3 equals what? First question. Step 2, 3, or 4, which one of those little rules did they use for this one? Which one of those 3 little rules should have recorded in your notes did they use? Very good. Number 3. Number 3 said if you pair up the numerators and pair up the denominators, so what are my blanks going to be? X over y. Very good. They went numerator, numerator, denominator, denominator. X over y. Very good. Questions about where they're getting that? They're literally just using those rules verbatim. And they're just seeing if you can recognize them. What's the only one that we did with a plus sign in it? Number 4. Most likely, number 5 is going to be number 4. If x over 6 equals y over 15, then x plus 6 over 6 equals... Very nice. Y plus 15 over 15. All they did, if they add the denominator here, then that's all they're going to do here. Add the denominator. Now, you may have one today, you may have one like this today. It says, example. It might say if 2 over 3 equals x over 4, then it'll say 5 over 3 equals what over 4? Now, they didn't put the plus sign in there, so you might be thinking, what the heck did 5 come from? But what did they do here? They added the denominator, just like here. The only difference is you don't see that plus sign to give it away. The only time today that they'll actually just change it like this is if they're using this rule. So what would this one be? What was that? It's not multiplication, it's addition. But you're right, it'd be x plus 4. Add that denominator as well. Let's look at 2 more. Decide whether the statement is true or false. True or false. I'm going to call people at random. Are they true or are they false? It'll be one of those 3 things we just looked at. All we're doing is reading and enforcing them. Sydney, what do you think? True or false? For number 7. Why do you think that? That's picking on you, right? Yeah. Well, what did they do? If you just look at this one and this one, what did they do? Just to get from this part to this part. They added the denominator, right? So, what did they do the same thing for this one? Yeah. So if they're consistent, then it's pretty much always going to be true. So this is, you're correct, true. True. Let's see. Clay, what about number 9? What do you think? Well, what 2 pieces did they put together? Let's look at this first one. Where did they get these 2 things? I can't hear you. Oh. Where did they get these 2 pieces from the original? Stacey, you want to help me out? Yeah, they're the 2 numerators. They just put these 2 together And then how did they get these two? They're the two denominators. Step 3, I believe it was the third one that we did from your notes, said if you have a proportion, you can just put the numerators together and you can put the denominators together, right? And if it's one of those 3 rules, then it is true. It is correct. Questions on these? They're just seeing how well you know the notes for the day. So if you didn't record them, they are in your book. You're more than welcome to flip back to them, but you may want to record them somewhere since your test is opened up. Question? All right. The next kind of examples in your book. Wrong page. And I appear to have lost my spot. You know what? I have other examples. Like this one. Now, notice the diagram. They will tell you the pieces to use in the directions every time. They will tell you the pieces to use. CB. What is CB in this picture? What's this measure? 6. Oh, hold on. So, 6 over BA. What is BA? We don't know it. If you don't know it, stick a variable on it. How about X? Equals DE. What is DE? 4. Over EF. What is EF? How do I solve? Okay. Follow the diagram. The piece that you don't know, stick an X in there for, and solve. And that's all you have to do on these. Cross multiply. You get 42 equals 4x. Divide both sides by 4. Somebody punch that in the calculator and let me know what you get. 42 over 4. 42 over 10.5 is what I got as well. Very good. Yeah, decimal fraction anything. Questions on that? No. All right. Believe it or not, that's. Let me flip back to the book, which for some unknown reason I closed. I'm pretty sure that's pretty much everything today. Of course, they just put that one in. They didn't give us any just straight up normal problems. One second. Let's see, BAD. I'm pretty sure that's pretty much everything. Let's see. Let's look at, here's an example in your book. Again, your book is an awesome resource. So when in doubt, look in your book for examples. Here's another one that they did. They said B over D, which would be, this one's a little different actually. Well, let's do the other side first. How long is BE? 18. Well, they didn't do this the way I would have done it. In fact, I'm going to cover this up and we're going to discuss it. I'm glad we're doing this one. I don't know that you'll have one this complicated today. You may not. But since it's already up. Alright, look what they gave us to work with. They said BD over DA. Do we know BD? No. Now, here's the thing. You can solve these however you want to. They're asking you for BD, and they're asking you for what? BA, which is like the whole side, right? This problem is only going to be complicated the way they drew it. I personally would relabel this. I'm going to call this side my X, because I can do that. BD over DA equals BE over EC. Finished. I'll solve for X. That'll be 6X equals 54. Divide both sides by 6, and you should get 9. If X is 9, then what's what's BD going to be? You jumped the gun. BD is 9, and BA would just be 9 plus 3. Very good. 12. Now, they set it up like this. They set it up like this. They went ahead and combined the sides. They used up that stuff we learned today. They did whole side over the piece of the side equals whole side, 18 plus 6, over piece of the side. Put that right. So, and they cross multiply. But you can do it however you want to. You can do it however you want to. Label the pieces whatever you want to label the pieces. Okay? Don't feel like just because they have something drawn, you have to use that. Yes, ma'am. Right here? Just to throw you off. Just to throw you off. Now, there may be other ways we're going to talk about later on. See, I'll tell you where all this is going, since you asked. Where this is going is we're going to be able to just look at shapes. I wouldn't even have to tell you they're proportional. Similar to the way I showed you to find ways that triangles were congruent, like side, 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 angle, side, angle. You're going to have to use that same stuff to figure out that they're proportional. Okay? And you're going to have to go back and use RPOC and TPOC and all that stuff again. For instance, now this isn't today, but since you asked, there will be time in the future where I say, prove that these two triangles are proportional to each other, and you're going to have to find pieces that they have in common. Now, does everybody see that there's two triangles in that picture? Yes, there is. One piece of those triangles is the exact same for both triangles. It's literally a part of the top triangle and the whole triangle. It's a side or an angle. Who can tell me which side or angle is the same for both triangles? Like it's literally the same. Yes, ma'am. What do you mean BDE? Yes, but I mean like if I asked you to tell that triangle was proportional to the whole triangle, what's one exact piece? You know how like there were triangles that laid on top of each other and they shared a side? What is a single piece that they share? What? Well, DE is a side to this triangle, but it's not a side to this triangle. It's just some random line down there. What's that? Again, BA is a side to this triangle, but it's not an entire side of that triangle. Everybody's giving me sides. Why is nobody even trying an angle? Angle B. Angle B is an angle of this triangle, and it's also an angle of the whole triangle. So this is coming. It's not today, but it's coming. You'd have to use the reflexive property of congruence, RPOC, to say that angle B is the same for both triangles. That stuff's going to be a recurring theme all year. So embrace it. Okay, anyway, here you go. Now, I'm going to change this to even, but there is an accompanying worksheet. We already did all the odds together. Well, it wasn't originally even. There you go. There's that, and I'm going to pass out a worksheet. Here's how I want you to do this. I want you to staple the worksheet to the back of your paper when you're done.